Hello Bobcats. In this video we're going to talk about the average atomic mass. So to start this out, let's discuss what the atomic mass unit. So the atomic mass unit, or AMU, unit, or AMU is 1/12 the mass of a carbon isotope. Okay, so what it is that the atomic mass unit had to be standardized, and to do that they took the mass of a carbon-12 isotope and divided by 12. And so it is really the relative mass of a proton or neutron of carbon-12 isotope. So what it is officially is that carbon-12 is 1.0000 AMU. So the proton or neutron of a carbon-12 is 1.000 AMUs, which is equal to 1.661 times 10 to the negative 24th grams. Now the reason I bring this up is because remember when we talked about the particles, we had the particle. Let's look at this. Let's make another list here again real quick. Then we have the mass in AMUs using this official or standardized mass AMU, and then the true mass of the particle in grams. Okay, so if we have an electron, and we know that the electron is 9.11 times 10 to the negative 28th grams, and we take and divide this value by this value, then we get atomic mass unit of 0.000549. And then if we look at a proton, and the proton had a mass of 1.673 times 10 to the negative 24th grams, and if I take this and divide it by this, you know that it's going to be just a little bit over 1, and it really is officially 1.007276. And then for a neutron, we had a mass of 1.675 times 10 to the negative 24th grams. And so the atomic mass unit based on the carbon-12 standard is 1.008665 AMUs. Now remember earlier I said that the relative masses or AMUs were 0, 1, and 1, and if you round it to the nearest whole number, yes, we still look at it as 0, 1, and 1. But the reason I do this is in a few minutes you'll see that they do atomic mass isotopes, or mass isotope, the mass of isotopes in these fractions or decimals, and it's due to the fact that an AMU is standardized to a carbon-12, and so there's a little bit of a difference here. And you'll understand it in just a minute. Okay, so now let's talk about the atomic mass or average atomic mass. So atomic mass is the weighted average of all of the naturally occurring isotopes. Okay, so what we mean here is that, I don't know if I spelled that right, but we'll see, isotopes. So if I took a handful of carbon, and I had a handful of carbon here, black dust, then there would be a certain amount of that carbon would be carbon 12, some of that carbon would be carbon 13, and some of that carbon would be carbon isotope carbon 14. And so, but they all have different abundances. Carbon 12 has the highest abundance, and carbon 14 has the least amount of abundance. And so this average atomic mass takes into account the different abundances of each isotope. Of the element. It's kind of like your grades that are weighted. You know that we have to account for each test, and we weight those tests at 60%, and then we have to account for each homework and weight the homework at 10% and so forth. Well, let's write the equation for atomic mass. How do we figure out atomic mass? So the atomic mass is equal to the relative abundance of the isotope times the mass of that isotope. So we'll say mass of isotope 1 plus relative abundance times the mass of isotope 2 sorry, misspelled it, isotope 2 plus, and on and on and on. So if you have 3 isotopes, you would take the relative abundance of each of those and multiply it by the mass of that isotope, and so forth. Now, what is relative abundance? All relative abundance is just the percent abundance divided by 100. Because the abundances are recorded or reported in percent abundance, and then we change that to relative by dividing it by 100 or moving the decimal place over two positions. Okay, so let's practice a couple of these. Again, atomic mass is the relative abundance times the mass of isotope 1 plus the relative abundance times the mass of isotope 2, and on and on and on, however many isotopes you have. And then again, relative abundance is just the percent abundance divided by 100. So let's practice a couple of problems and see how this works. Okay, let's look at chlorine again. So if I have chlorine 35, and we know that it has a mass, an average atomic mass of, the isotope mass is equal to 34.969 AMUs. Now remember, this is 35, and that's a whole number, but because we are standardizing it to that carbon, it's just slightly smaller. So it's got an atomic mass unit of 34.969, but if you rounded that to a whole number, that would be 35. And it has an abundance equal to 75.78%. And then if we have chlorine 17, or 37, I mean, chlorine 37, it has a mass, an isotope mass, equal to 36.966. So it's slightly smaller, but if you round that, that'd be isotope 37 AMUs. And then it has an abundance equal to 24.22%. Now the abundances have to add up to be 100%. And so if you're missing, let's say they don't report a percentage, then you know that you just take 100 minus whatever the other percent is, and that'll give you that percentage. So to figure out the atomic mass of this element, we take the percent divided by 100, which gives us relative abundance, times 34.969 AMUs. That's the mass of that isotope, isotope 35, plus 24.22% divided by 100 to give us relative abundance, times the mass of isotope 37, which would be 36.966 AMU. And I'm just going to write under here, when I multiply, divide and multiply, I'll get 26.500 AMU, and this one will come out to be 8.953 AMUs. And so when we add those two, you get 35.453 atomic mass units. And that is the atomic mass, average atomic mass of chlorine. And we take into account each of those abundances. And so that, we will stop with that for this video, and I will see you next video.